Linear inequalities with two variables. There's a whole lot of information going on here, and it's in bold. You can see different definitions of what this might mean. Anytime you have y is greater than 1/2 x plus 1, so y equals mx plus b form, that's that first scenario. Or ax plus by is c, that's that second scenario. Or y is greater than or equal to x, that's another y is mx plus b form. You are presented with a linear inequality. Okay, we've done linear equations up to this point. All right, if they're not equal, they're called inequalities. All right, inequalities. Now, solutions to an inequality represent any number that would make a statement true. Okay, if you're doing an equation, it's generally only one answer, right? It's generally only one answer. That's why I had you guys read this. I know we didn't have a ton of time here, but just for sake of argument, I'm going to point a few things out to you that I know you could read on your own, should you choose to do so. But in any case, when you graph these things, what you're really going to be graphing is the equation that it would be if it were equal. Okay? After you've graphed that, you determine to yourself whether or not below, above, or the line and below, or the line and below, the line and above or the line and below are true. Okay? Hit that front light for me, Okay? So it depends upon what type of an equation you're dealing with, what type of an inequality you're dealing with. Only the front one. Only the front one. So back one needs to stay on. Thank you. All right. Let's take a look at the top of page 136. Okay? Page 136. They give us y is greater than or equal to 1/2 x plus 1, and they give us y is less than or equal to 1/2 x plus 1. All right, and for sake of argument here, I'm going to just quickly explain that the 1 is your y-intercept. So I'm going to go up to 1 and put a point there. And my slope is 1/2, which is up 1 and to the right 2. Okay? So now I can visualize what this might look like. Okay? If this is a solid line, and I just leave it as a line, then what I have graphed is the equation. But notice, they say greater than or equal to. So now I have to make a determination. What kind of a line am I going to draw? Well, back in, I'll say pre-algebra, we learned that open circles identify a line on a line graph if it's greater than. Closed circles identify a point and a line on a line graph if it's less than or greater than or equal to. So this has the equal to scenario, which means it is a solid line. Okay? If it was just greater than, it would be dotted. Okay? Now, we have to figure out, what do we graph? Now you're seeing that the above portion is already graphed, but how did they figure that out? Okay, well, greater than, that means it's everything above. Do not assume that. Find a point, perhaps a simple point, that is on one side or the other. Notice I selected 0, 2 as my test point. Find a point and then plug it into the equation to see if this side is true. They've already shaded it as being true, but they didn't explain why. So here we go. 2 is greater than or equal to 1/2 of 0 plus 1. 2 is greater than or equal to 1. Is that true? Okay, since this dot represented by those points is true, then that means everything on this side can be shaded as true. All right? In the same way, were I to do the same scenario over here, again, 1 is my y-intercept, up 1 over 2 is my other thing. It's greater than, or it's less than or equal to, so I am going to have a solid line. And I am going to test a point on the side that they've already told me is true. Okay, only for proof. Only for proof in this situation. Okay? We're going to test 0, 0, which is right here. Okay? We're going to test 0, 0. That's this point right here. So I am going to fill in 0 is less than or equal to 1/2 of 0 plus 1. 0 is less than or equal to 1? Why, yes it is. So this side, true, should be shaded. All right? That in a nutshell is what we're going to be dealing with today. I'm going to start with their example 1. Example 1. They say graph 3x plus 2y plus 4 is greater than or equal to 0. Okay, first thing I'm going to tell you you want to do is exchange it, transform it into y is mx plus b form. Okay, obviously it's greater than or equal to, but I'm just talking about y-intercept form here. All right, in order to do that, I'm going to subtract my 3x and my 4 so that they go where my 0 is. 2y is greater than or equal to negative 3x minus 4. Does everybody see that step? In order for it to be proper, you have to have y with a coefficient of 1. So I'm going to divide everything by 2. Y is greater than or equal to negative 3/2 x minus 2. Y-intercept, slope. Graph it. Y-intercept is a negative 2. 1, 2. There's my y-intercept. Okay? My slope is down 3, right 2. Negative 3, right 2. It's where that crosses, so it's like that. Since it is greater than or equal to, this line is solid. Now I have to make a decision. Which side do they shade? Well, despite the fact that the book shows you which side they shade, I'm going to assume that they didn't show you, and we're going to test. And whenever I can, I use 0, 0. If 0, 0 results in a true statement, then I'm shading the right. If 0, 0 is false, then I'm shading the left. And I am going to plug 0, 0 into this equation. 0 is greater than or equal to negative 3/2 times 0 minus 2. 0 is greater than or equal to negative 2, true or false? This side receives the shading. Without the shading, your answer is wrong. Without the shading, with the line only, you graphed the linear equation, not the inequation or inequality. Okay, that's example 1. Let's go on to example 2, where we'll start to see how you're not always going to have a solid line. Okay? Here's example 2. 5x minus 4y is greater than 10, minus 4y is greater than 10. So, let's convert this to y equals mx plus b form by removing our x. Negative 4y is greater than negative 5x plus 10. When you divide by a negative in an inequality, what happens to the greater than or less than symbol? Does anybody remember? You betcha. Divide everything by your negative 4, and you're going to end up with y is less than, a negative by a negative is a positive, and negative 10/4 is a negative, can we just call it a negative 5/2? All right? Negative 5/2. To graph this, sketch out our little line. Negative 5/2, what is that? 2 1/2, right? So 1, 2 1/2. All right, and up 5 over 4. 1, well, let me draw some more lines. 1, 2, 3, 4, 5. 1, 2, 3, 4. Something like that. Mine isn't nearly as pretty as theirs is. Okay, but on graph paper it would be. Now, because it is less than, not less than or equal to, remember we flipped the sign because we divided by a negative, that means that our line is going to be dotted. Okay, because it is not equal to the points that live on that line. If you recall, the place I like to test is 0, 0. And there it is. If this side is true, everything is true. If the 0, 0 is false, then this side must be true. Let's plug it in. 0 is less than 5/4 times 0 minus 5/2. Is 0 less than negative 5/2? No, it is not. So in contrast of what we've been seeing, this proved that this side does not include the truth, which means the other side does include the truth. Okay? So you'll shade the other side, just like that. Okay? That is example 2. Okay? We've only got 3 more examples of this before I can let you get to work.